Alright, so the concept of scale has to do with relative sizes. So scale drawings or scale models of real-world things um, would be the same shape as the real world object, but not the same size. And that's a lot of times for practical reasons. You know, if I'm going to draw a map of Kenya, I don't want the map to have to be the same size as Kenya. That would be a gigantic map, and it would be totally useless because why use a map of Kenya that's the size of Kenya when you've already got the actual country right there, right? So you want to have a scale drawing that allows you to know things about the real object, but in a more convenient way. So for example, here's a scale drawing of a sperm whale. Here's a picture of a real sperm whale. This drawing is to scale, which means that the corresponding lengths are have the same proportion. So, for example, the length of his back, or I say like this scale drawing uh, is is a scale drawing of this sperm whale. Okay, maybe this is just an idealized sperm whale, but pretend that a scientist was observing this specific sperm whale and then drew a scale drawing. What that would mean is, for example, the length of the back of the whale on the drawing is the same proportion, or the proportion of the length of the back on the drawing to the length of the real back of the sperm whale is the same proportion as, or is proportional to the ratio of the length of this part of the whale, the head or front of the head or face or whatever that is, to the real face. And that's what makes this the same shape as the real object. Everything is proportional. So the scale of a scale drawing or scale model is the ratio between the corresponding lengths. So the scale here is 1 to 200, which means that, um, for example, this, let's call this the face. It's not really, it doesn't really have a face, but the front of the whale. The length of this, whatever it is, I don't know, 10 feet, is 1/200th the size or the length of the real thing here. Also, the length of the back is 1/200th the length of the real back. Does that make sense? So that's why this thing is the same shape, is that all the corresponding lengths have the same ratio. It's the ratio of 1 to 200. So this scale drawing is 1/200th the size of the real whale. So this is a scale drawing, and its scale is that ratio that defines, um, how much smaller is the scale drawing than the real object, right? So that's the idea of scale. It's relative sizes, um, and yeah, it has to do with ratios and corresponding sides. And here's some examples. Scientific drawing, and here's a scale model of a city, I believe Shanghai, where the artists are purposely doing this to scale, which means that the ratio of each corresponding measurement to the real object, the real city, is always the same. So let's pretend, I have no idea what the actual scale is here. Let's pretend that this scale model is has a scale of 1 to 300. That means a length of 1 foot on the scale model corresponds to 300 feet in real life. So if this is 1 foot high, um, then the real building is 300 feet high. If this is I don't know. If from this road to this road is 2 feet, then in real life that's a distance of 600 feet. 2 times 300. So that's scale.